Hello everyone. Today we're going over the zero product law. Please take a moment to read it. So what it basically says is like if you, after you factor a polynomial and you set it equal to zero, the factors will be equal to zero if one of the factor is equal to zero. So we are going to apply that method by using these 4 steps. So first step is to make sure that we move everything equal to zero. So for equation 1, we don't really have to do that. And then we go on to factoring. So the first step of factoring for this one is making sure we label our ABC. So our A is equal to 1, B is equals to negative 10, and C is equal to 21. And then after that, we make our table, 2 number that multiplies to A times C, which is 21, and adds up to a negative 10, which is our B value. And those numbers that is going to give us is 7 times 3. It multiplies to positive 21, but it adds up to a positive 10. So we don't want that. We need a negative 10. So we're going to make sure that we turn both of them into a negative, because negative times a negative is positive, which does add up to a negative 10 for us. Okay, so perfect. So if I bring down my x squared and then I bring down my positive 21 and write down negative 7x and then negative 3x, set it equal to 0, I get x parentheses x minus 7 and negative 3x minus 7. And notice like with like our a value equals to 1, we don't really need to do the grouping process that we did in like the step before, because our factors end up being the 2 numbers that we found. So it's when the a value is equal to 1, we could actually jump right into doing the 2 factor bubbles, like the 2 parentheses. Okay, so now is the new part. We take one of our factors, we set it equal to 0. And then when I add 3 on both sides, we get x is equal to 3. And then for this one, x minus 7 is equal to 0, plus 7 plus 7, x is equal to 7. And then we can end up having our 2 solution set is 3, 7. And that's it, we're done. Let's take a look at the second one. The second one is 9x squared minus 25 is equal to 0. So this one is a difference of perfect square. So this one, we can do it just right away. We know that the first one is going to be 3x and 3x for our 9x squared. So I have 3x times 3x. And then the minus 25 is going to be plus 5 and minus 5 equals to 0. Same idea, we set it equal to 0. 3x plus 5 is equal to 0. Minus 5 minus 5, 3x is equal to negative 5. Divide by 3, x is equal to negative 5 over 3. Same for the next one. 3x minus 5 is equal to 0. Plus 5 plus 5. 3x is equals to positive 5, and x is equals to 5 over 3. And for our solution set, you could write it as negative 5 over 3, comma 5 over 3, or you could write it as 2 of them together. And I'm going to actually show you the or, how to do it algebraically as well. So you could write it as plus or minus 5 over 3. Another way of doing this problem is like if you have 9x squared minus 25 is equal to 0, you take the approach of inverse operation. You add 25 on both sides. You get 9x squared is equals to 25, and then you divide by 9. And you get x squared is equals to 25 over 9. And then to get rid of the exponent of 2, you take a square root. When you do that, you end up getting x is equals to positive and negative 5 over 9, because radical 25 is 5, and then radical 9 is 9. Because 5 times 5 is 25, negative 5 times negative 5 is also equals to 25. So that's why we consider both. Let's take up the next one. The next one, we have to set it equal to 0. We minus x, and then we have to subtract 4 as well. Minus 4 minus 4. which leaves us with x squared plus 10x, 29 minus 4 is 25, is equal to 0. And then since a value is equal to 1, we can just look for a 2 number that multiplies to 25 and adds up to 10, which is 5 times 5. So it's x plus 5, and x plus 5 equals to 0. So for this one, when I set them equal to 0, since they're both the same thing, I could just do it to one of them, and x is equals to going to be a negative 5. So when I set up my solution set, is just going to be negative 5. And like one thing to make sure, like for all of these things, that when we end up graphing them, for our graphs, for our parabola, 1, 2, 3, 4, 5, 6, 7, our parabola will definitely touch at this 3 and this 7. And like for this one, it's going to be an upward looking graph. Just for the length of the video, I'm not putting in the calculator, but you will always touch these points. Same goes for like the next graph as well. Like you will end up touching the 5/3. Same for like our last one, that if we do end up graphing this 1, 2, 3, 4, 5, we will definitely go through this negative 5 for our graph. So that's something we need to make sure that we plot the points to check. All right, that's about it. Make sure you jot down all the notes and bring it to class if you have any questions.